Let us discuss the numericals from thermodynamics. First numerical we will see the heat liberated on complete combustion. The heat liberated on complete combustion of 7.8 gram benzene is 327 kilojoule. This heat has been measured. This heat has been measured at constant volume and at 27 degrees Celsius. Calculate heat of combustion. Of benzene at constant pressure. And at 27 degrees Celsius. Capital R given, universal gas constant given 8.3 into joule per Kelvin per mole. So, now what is the given data? You see that here. The given data is the heat liberated on complete combustion of 7.8 gram of benzene. So 7.8 gram of benzene. 7.8 gram of benzene on complete combustion liberates. On complete combustion liberates how much heat? 327 kilojoule. 327 kilojoule of heat is liberated. 327 kilojoule of heat is liberated. Okay. Now what they are asking in the sense, find heat of combustion of benzene at constant pressure, delta H. Delta CH we have to find. That means heat of combustion or enthalpy of combustion means how much benzene should burn. 1 mole of benzene should burn. 1 mole of benzene should burn. Therefore, we have to take 1 mole of benzene we have to take. Okay. So 1 mole of benzene in the sense gram molecular mass. That is how much in the sense 78 gram. 78 gram is 1 mole of benzene. 1 mole of benzene. That is so 78 gram is 1 mole of benzene. So 78 gram of benzene on combustion liberates how much amount of energy? 3270 kilojoule of heat is liberated. Okay. So and so amount of heat is liberated at what condition? You see, constant volume. Constant volume means it is delta U. Therefore, delta Cu is equal to 3270 kilojoule. Liberated means minus exothermic. So delta Cu is given. Internal energy of combustion is given. But what is asked? Heat of combustion at constant pressure. That means delta H they are asking. So how to find delta H? So delta CH is equal to what we can say means delta Cu plus delta Ng RT. Like this we have to write equation. So delta CH we have to find. Delta Cu we will substitute minus 3270 kilojoule we have substituted. Delta Ng we want. Delta Ng in the sense we have to write the equation. What equation means? Benzene undergoes combustion. Okay, that equation we have to write. So let us write the equation. Benzene undergoes combustion. So benzene will take, benzene is a liquid. Combustion in the sense plus O2 gas. Now carbon takes oxygen and gives carbon dioxide gas. H takes oxygen and gives water. Water we have to write in liquid state unless they are mentioning as vapor. Okay. So water we have to write as a normal condition only. What is a normal condition in the sense liquid we have to write. Water we have to write it as a liquid. Okay. Then we have to balance this equation by keeping benzene as 1 mole. Okay, which is undergoing combustion, that we have to keep as 1 mole and the rest we have to balance. Okay, so this has to be 1 mole. So 6 carbons present, therefore 6 carbon dioxide, 6 hydrogen, therefore 3 H2O, and oxygen we have to see 6 into 2, 12, here 3, 15, therefore 15 by 2. Okay, 15 by 2. It is equation is balanced. Here we have balanced the equation by keeping benzene as 1 mole. Okay, we are balancing the equation by keeping benzene as 1 mole. Okay, then delta Ng we have to find. Delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. Gaseous products. First we will see which are products. Products carbon dioxide and water. In that we have to see gas. Carbon dioxide is gas. That moles we have to take. Then reactants we have to take. This is the reactants. In reactants we have to take only gas. That is oxygen. So oxygen is how much? 15 by 2. Therefore how much we are getting? 1.5 moles. So delta Ng we got. That delta Ng is minus 1.5 moles. Okay, minus 1.5 moles. So delta Ng will substitute 1.5 moles minus 1.5 moles into R. R value is given how much in the sense 8.3. 8.3 given here, 8.3 joule per Kelvin per mole given. Already we have substituted here kilojoule. Therefore, substitute this R in kilojoule we have to substitute. Okay. So kilojoule in the sense 10 power minus 3 kilojoule per Kelvin per mole. So we have substituted what in the sense R we have substituted. Then temperature we have to substitute. Temperature is given 27 degrees Celsius. 27 degrees Celsius. Convert into Kelvin. Therefore, 300 Kelvin. Okay. So this on simplification we are getting a enthalpy of combustion or heat of combustion, that is how much in the sense minus 3273.74 kilojoule. Okay, this is a heat of combustion. Now this heat of combustion symbol is what in the sense delta Ch. Why delta Ch in the sense heat of combustion at constant pressure they are asking. Enthalpy of combustion at constant pressure, therefore only. Okay, let us go to next question. The molar heats of combustion of combustion of acetylene gas, acetylene C2H2 gas, acetylene gas, graphite, carbon graphite, and hydrogen H2 gas, or 310 or 310.62, 310.62, 94.05, 94.05 and 68.32 and 68.32 kilocalories respectively. Calculate heat of formation of acetylene. Calculate heat of formation of acetylene. Calculate heat of formation of acetylene. Okay. Calculate heat of formation of acetylene. Okay. So now we have to find a heat of formation of acetylene. We have to find now. Okay. So how to find that? That we'll see. First, what is the given data? We'll see. The given data is a heat of combustion of acetylene. Okay, so heat of combustion of acetylene in the sense combustion of acetylene. Acetylene is burning. So we'll take acetylene, C2H2 gas. Combustion in the sense plus O2 gas. Carbon reacts with oxygen to give carbon dioxide gas. Hydrogen reacts with oxygen to give water liquid. Okay. Now we have to balance the equation by keeping acetylene as 1 mole. Acetylene is 1 mole. Okay. So 1 mole of acetylene. Carbon 2, therefore 2 write it. Hydrogen 2 balance. Oxygen we have to balance. 2 2s are 4. Here 1 5. Therefore 5 by 2. Okay. Therefore oxygen we have written 5 by 2 we have written for oxygen. Sorry. For this, what is a delta H? For this, delta H is how much in the sense 310.62. 310.62 unit is what means here kilocalories given. That kilocalories will write. Then combustion in the sense heat will be liberated. Therefore, negative sign you have to write. Okay. Combustion in the sense heat will be liberated. Therefore, you have to write negative sign. Generally, combustion means a negative sign we have to write. Okay. except in one case, when in which case, in the sense nitrogen combining with oxygen to give nitric oxide. That case only positive endothermic. In the rest of the cases, combustion means exothermic minus, we have to write. Then we have to take graphite. So graphite solid plus oxygen gas gives what, in the sense carbon dioxide gas. Graphite combining with oxygen. Graphite undergoes combustion with oxygen to give carbon dioxide gas. For this delta CH, we will see enthalpy of combustion. For graphite, how much given, in the sense 94.05. Write minus 94.05, write it. Why? Because combustion means exothermic. Then combustion of hydrogen. So hydrogen gas, you take it, plus oxygen gas, you write. Hydrogen combining with oxygen to give what, in the sense water. Here, what is the delta CH? Delta CH, how much means minus 68.32 kilocalories. Then we have to balance the equation. Oxygen only we have to balance like this. Keep hydrogen 1 mole. Why? Because it is undergoing combustion. It is combustion. Okay, therefore keep 1 mole. So we have written respective equations. We have written. So what they are asking us to do? They are asking us to find heat of formation of acetylene. Okay, they are asking us to find heat of formation of acetylene. What is forming? Acetylene is forming. Acetylene is forming in the sense acetylene is the product. Acetylene is the product. So left side, what you have to write? Constituent elements we have to write. In acetylene, what is the constituent elements? Carbon and hydrogen. So carbon we have to take in standard state, that is what means graphite solid, and hydrogen is H2 gas. Then we have to balance the equation by keeping acetylene as 1 mole. So keep acetylene as 1 mole, therefore carbon is 2, therefore 2. Hydrogen is balanced. This is called a heat of formation of acetylene. Heat of formation of acetylene gas. This value we have to find it. How to find this value, in the sense by using these three equations, this number 1, number 2, number 3. Using number 1, number 2, number 3, we have to find a heat of formation of acetylene. We have to find it. So for that case, what we have to do? Here in the required equation, acetylene is in right side. In the first equation, acetylene is in left side. Therefore reverse first equation. So we are reversing first equation. First equation we are reversing means 2 carbon dioxide left side, H2O liquid left side, then acetylene right side. Acetylene goes to right side. 5 by 2 O2 goes to right side. Then delta H. Delta H becomes plus 310.62. Why plus 310? In the sense because we have reversed the equation. Then in the required equation, we want to graphite in which place, in the sense left side. In the second equation also, graphite is in left side. Therefore, take second equation as it is. So we are taking second equation as it is. That is a graphite solid plus O2 gas gives what, in the sense carbon dioxide gas. For this delta H is given. Delta H is how much, in the sense minus 94.05 kilocalorie given. In the required equation, we need 2 times graphite. Therefore, multiply the second equation by 2. Multiply the second equation by 2. Therefore, 2 times graphite, 2 times O2, 2 times carbon dioxide. Therefore, delta H also multiply by 2. This minus 94.05 also multiply by 2. Okay. Then in the required equation, we have H2 in the left side. In the required equation, we have H2 in the left side. That H2 is available in the third equation. In left side only is there. Therefore, third equation, you write it as it is. So third equation we are writing as it is. H2 gas plus half O2 gas. Half O2 gas gives H2O liquid. H2O liquid. For that, what is the delta H, in the sense minus 68.32 kilocalories. Minus 68.32 kilocalories, we can say. Now let us add all these three equations. Let us add all the three equations. We will add. We are going to add all the three equations. Okay. Now, what are the common things that we will cancel? Carbon dioxide gas, we are cancelling. Then water liquid, we are cancelling. Water liquid, we are cancelling. Then oxygen, if you see 2 plus of 2 and half, here also 2 and half is there. Therefore, O2 also will cancel. So what is the rest, in the sense here graphite is there, graphite plus H2 gas. Then here what is there means acetylene gas is there. Now for this we have to find delta H. Delta H is called heat of formation of acetylene. That means this delta H, how to get means add all the delta H values, or add all the delta H values. You will get heat of formation of acetylene. You will get it. So heat of formation of acetylene is how much in the sense plus 54.2 kilocalories. Heat of formation of acetylene is plus 54.2 kilocalories is coming. Okay. Let us go for next sum. From the standard enthalpies of combustion, from the standard enthalpies of combustion, standard enthalpies of combustion, from the standard enthalpies of combustion given below in kilojoule per mole, and standard enthalpy of acetylene, and standard enthalpy of acetylene, standard enthalpy of acetylene, standard enthalpy of acetylene. Find the standard enthalpy change, standard enthalpy change. Find the standard enthalpy change when acetylene is hydrogenated, when acetylene is hydrogenated, when acetylene is hydrogenated to ethane, when acetylene is hydrogenated to ethane. Okay. Now for carbon, how much given in the sense minus 394, for hydrogen minus 286, hydrogen minus 286, ethane C2H6, ethane minus 1560, minus 1560 for ethane. Then acetylene C2H2 plus 227. Acetylene how much given means plus 227 given. Okay. So these are the given data, and the required thing we have to find it. Sir, what is the required, what is a given data? You see, standard enthalpy of combustion, standard enthalpy of combustion of what in the sense, standard enthalpy of combustion of carbon, hydrogen, and what in the sense ethane. Okay. Standard enthalpy of combustion of carbon is given, hydrogen is given, and ethane is given. For this we will write respective equation. Combustion of carbon, combustion of carbon in the sense we will take carbon in graphite solid plus O2 gives CO2. For this delta CH, standard enthalpy of combustion of graphite is how much means minus 394 kilojoule per mole. Okay. Then hydrogen, combustion of hydrogen, hydrogen combustion in the sense H2 gas plus O2 gas gives H2O liquid. For that standard enthalpy of combustion is how much in the sense minus 286 kilojoule. Then ethane combustion, ethane combustion means C2H6 gas plus O2 gas gives 2 CO2 gas plus 3 H2O liquid, 3 H2O liquid. Okay. 3 H2O liquid. Now this we have to balance. Carbon is over, hydrogen is over, oxygen 2 2s are 4, here 3 7, therefore 7 by 2. Here delta CH naught, delta CH naught is minus 1560 kilojoule. Sir, heat of combustion of ethane is given. Next, what is given in the sense standard enthalpy of acetylene, standard enthalpy of acetylene is given. Standard enthalpy of acetylene in the sense standard enthalpy of formation of acetylene, that is the meaning. Standard enthalpy of acetylene meaning is what means standard enthalpy of formation of acetylene, that is the meaning. So formation of acetylene in the sense acetylene we have to write in the product side, and left side we have to write constituent elements. We have to write one is graphite, another one is H2 gas. Then we have to balance the equation by keeping acetylene as 1 mole. For this delta FH not given, delta FH not for acetylene how much means 227 kilojoule, 227 kilojoule given. Sir, what they are asking us to find, they are asking us to find a delta H naught of acetylene hydrogenated to ethane. That means what is the equation, required equation? Hydrogenation of acetylene. Hydrogenation of acetylene means acetylene combining with hydrogen, that is the meaning. Hydrogenation of acetylene means acetylene combining with hydrogen, that is called hydrogenation. So which is hydrogenating? Acetylene is undergoing hydrogenation. So acetylene plus hydrogen gives what? gives what? Ethane. Ethane formula is what? C2H6. So ethane we are getting by the combustion, by the hydrogenation of acetylene. Acetylene formula C2H2, that is combining with the hydrogen to give ethane. Ethane contains 6 hydrogens, therefore 2H2 you take. For this delta H naught we have to find. For this delta H naught we have to find. Okay, so we have to find the hydrogenation of what? In the sense acetylene. Hydrogenation of acetylene. Okay, so this equation is the required equation. So what we have to do? How to get this equation from these? That we'll see. We want acetylene in left side. Where acetylene is available, you see acetylene is available in this equation. So you take these equations like this. So acetylene is available in the fourth equation. Therefore, what you have to do means reverse the fourth equation. Why we have to reverse the fourth equation? We want acetylene in the left side. Okay, that is available in the fourth equation, but in right side. So in order to bring acetylene left side, reverse this fourth equation. Okay, so we are reversing what? In the sense fourth equation we are reversing. Okay, reverse fourth equation. So on reversing this fourth equation, we can write we can get acetylene, sorry, we can get acetylene in left side. So acetylene C2H2, C2H2 gas gives 2 times carbon in graphite, 2 times carbon, that is graphite solid, plus H2 gas. For this delta H, for this delta H, how much? In the sense we are reversing, therefore minus 227 we have to write, minus 227 kilojoule. Okay, so acetylene is over. Sorry, so fourth equation we have reversed. Next we want H2. How much H2 we want? Hydrogen we want in left side. That hydrogen is available in second equation, therefore take second equation now. Okay, so we have to take second equation now. Okay, so we are taking equation 2. Equation 2 we are taking, that is what? In the sense H2 gas plus half O2 gas gives H2O liquid, H2O liquid. For that delta H is how much? In the sense minus 286, minus 286 kilojoule. Okay, so hydrogen we got. In the required equation, hydrogen, if you see 2 times H2 is there, therefore you have to multiply second equation by 2, because 2 times H2 we want. So multiply the second equation by 2, therefore 2H2, therefore if this you multiply with 2, therefore this 2 into half becomes 1. Okay, so you are multiplying this with 2, therefore it becomes 1. Then you are multiplying this by 2. This also you multiply by 2. Minus 286 is there, no? That also you have to multiply by 2. Okay, sorry, H2 is over. Next, ethane is there in the required equation. Ethane is there in the right side. That ethane is available in which place? Means in equation number 3. We want ethane in right side, but in equation number 3, ethane is in left side. Therefore, reverse equation number 3. Okay, equation number 3 we have to reverse it. Okay, so we are reversing equation number 3. Sir, equation number 3 on reversing gives what? In the sense 2 times carbon dioxide, 3 times H2O, 3 times H2O. Then ethane C2H6 plus 7 by 2 O2. For this, what is the delta H? In the sense that minus 1560 plus becomes plus 1560 kilojoule. Okay, so we got ethane. Then if you see here, graphite is there. This graphite has to be cancelled. This graphite has to be cancelled. In the required equation, graphite is not there. So we have to cancel the graphite. In the required equation, graphite is not there, but in the written equations, graphite is there. In order to cancel the graphite, take equation number 1. Okay, take equation number 1. So we are taking a equation number 1. We are taking, that is what? In the sense graphite solid plus O2 gas gives CO2 gas, CO2 gas. For this, what is the delta H? Means minus 394, minus 394 kilojoule, minus 394 kilojoule. Now, why we have taken this equation? In the sense, in order to cancel this graphite with this graphite. Here graphite 2 times is there, so multiply this equation by 2. Okay, why we have to multiply this by 2? Then only graphite will become 2 times. This graphite 2 times will get cancelled. So we are multiplying this by 2. Okay, then multiply this delta H also by 2. Now we will add these equations. Then we will get required equation. So we will cancel the graphite. Graphite we have cancelled. Then what are the things are getting cancelled? You see, carbon dioxide is getting cancelled. Water has to be cancelled here. here 3 water molecules are there, but here only 2 water molecules are there. How water will be cancelled then? Okay, so what we have to do in the sense, we have multiplied equation 2 by 2. So multiply equation 2 by 3. Equation 2 by 3. Multiply equation 2 by 3. Therefore here 3 by 2. Here also multiply by 3. So here also multiply by 3. Now water we can cancel. Okay, water is cancelled. Then hydrogen. Hydrogen here 1 hydrogen, here 3 hydrogens, cancelling means remaining 2 hydrogens present. Oxygen we have to cancel, here 3 by 2 O2, here 2. Therefore how much means totally 3.5, 3.5 O2, 3.5 O2 cancels. So what is the remaining means acetylene is there in the left side. That acetylene we will write. Then hydrogen 2 times remaining is there, that 2 times hydrogen we will take. Then here ethane is there in right side, ethane we will take. Now delta H. Delta H means add all these delta H, we will get required delta H, we will get the required delta H how much in the sense minus 313 kilojoule. Okay, this is called what means heat of formation of heat of hydrogenation of acetylene. We can say heat of hydrogenation of acetylene, we can say. Okay, sir. Let us go to next sum. We will go to next sum. We will go. The sum is when 2 moles of ethane gas, when 2 moles of ethane gas, when 2 moles of ethane gas are completely burnt, or completely burnt, 3129 kilojoule of heat is liberated. 3129 kilojoule of heat is liberated. Heat is liberated. Okay. Calculate the heat of formation of calculate the heat of formation of ethane in gaseous state. Ethane in gaseous state. Delta HF for CO2 gas. Delta HF for CO2 gas. Delta HF for CO2 gas and H2O liquid or H2O liquid or minus 395 and minus 286 and minus 286 kilojoule per mole respectively. Kilojoule per mole respectively. Kilojoule per mole respectively. Sir, okay. Now, what is the question asked in the sense? 2 moles of ethane is completely burning, while this much heat is liberated. 2 moles of ethane on complete combustion, this much amount of heat is liberated is the given data. Okay, so now we will take ethane undergoing combustion. For that equation we will write ethane combining with oxygen to give carbon dioxide and water. Okay, so this is a 2 carbon. Now we should not take 2 carbons. They said 2 moles of ethane undergoing combustion. No, therefore make 2 moles of ethane. Okay, 2 moles of ethane. Therefore carbon is 4. Okay, hydrogen is 2 into 6, 12. 12 in the sense 6 we will take. Oxygen we have to balance. 4 into 2, 8. Here 6. Therefore 14. So therefore 7 into 2. Like this we can take. Okay. So we have balanced what in the sense we have balanced oxygen. We have balanced. Now we will see delta H for this. So here 2 moles of ethane is combining, 2 moles of ethane is burning. So how much heat is liberated? 3129. So we will take minus 3129. Minus 3129 kilojoule we said. Okay. So here why we have taken 2 moles of ethane in the sense they said 3129 kilojoule of heat is liberated when 2 moles of ethane undergoes combustion. Therefore only we have taken 2 here. Therefore, this delta H is not enthalpy of combustion. If you divide this by 2, then only we will get enthalpy of combustion we will get. Okay, sir. Next we will say calculate enthalpy of formation of ethane. Enthalpy of formation of ethane they are asking. Okay, so formation of ethane in the sense C2H6 we will write this side. Now formation of ethane means ethane we have written in the right side. Now left side we will write constituent elements. Constituent elements is what means graphite solid, then hydrogen, okay, hydrogen gas. It is this we have balanced by keeping ethane as 1 mole. Now this is called the enthalpy of formation of ethane gas, we can say. This we have to find it. Okay. And then what is other given data? Enthalpy of formation of carbon dioxide and water is given. Carbon dioxide and water. Carbon dioxide minus 395, water minus 286. Okay. So enthalpy of formation of carbon dioxide. So carbon dioxide is forming, therefore it is a product. Constituent elements is the left side. Constituent elements in the sense graphite solid plus O2 gas. For this enthalpy of combustion, enthalpy of formation is given. Enthalpy of formation of carbon dioxide gas. Enthalpy of formation of carbon dioxide gas is minus 395 kilojoule. This we can also call it as enthalpy of combustion of graphite also we can say. Next given is enthalpy of formation of water liquid given. So for this constituent elements is what means H2 gas plus of O2 gas, of O2 gas. For this here enthalpy of formation of water is given, that is how much in the sense minus 286, minus 286 kilojoule. Okay. So these are the given equations. So given equations number 1, number 2, number 3. Required equation we have written here. So in the required equation ethane is there in the right side is there. Therefore, reverse the equation number 1. Reverse equation number 1. So we are reversing equation number 1. Okay, reversing equation number 1. So what we will get means 4 times carbon dioxide, 6 times water gives 2 times ethane, 2 times ethane, then 7 O2, delta H is equal to minus 3129 kilojoule. Okay. Then we want in the required equation, we want ethane in the which side in the sense right side. How many moles means 1 mole. But in this written equation, ethane is there in 2 moles is there. Therefore, divide this equation by 2. So we are dividing this equation by 2. Therefore, this 4 becomes 2, 6 becomes 3, this 2 becomes 1, 7 becomes 7 by 2. 7 by 2 we can say. Okay. Therefore, we said 4 becomes 2, 6 becomes 3, this 2 becomes 1, 7 becomes 7 by 2. This also you divide by 2. Okay. This delta H also we have to divide by 2. Okay. That we have completed. Next, ethane we have completed. Next, we want in the required equation, we want graphite. In the required equation, we want graphite that is available in equation number 2. So equation number 2 we are taking, that is equation number 2 contains graphite solid plus O2 gas gives what in the sense CO2 gas, delta H is equal to minus 395 kilojoule. In the required equation, we want graphite 2 times, therefore multiply this equation 2 by 2. So if you multiply by 2, so 2 times graphite, 2 times O2, 2 times CO2, multiply 395 also by 2. Minus 395, you multiply by 2. Okay, sir. Then in the required equation, we want 3H2. Therefore, take equation number 3, H2 is available, and multiply equation number 3 by 3. Okay, equation number 3 by 3 you are multiplying. So 3H2 gas plus 3 by 2 O2 gas, 3 by 2 O2 gas gives 3H2O liquid. 3H2O liquid delta H is equal to how much in the sense minus 286 into 3 kilojoule. Okay, so now what we will do in the sense, let us add all the equations. Let us add all the equations. Okay, now what are the common things that you cancel it? Carbon dioxide gas is cancelling, water liquid is cancelling, then O2 here 3.5 O2, here also 3.5 O2 get cancelled. So graphite solid plus 3H2 gas, gives ethane gas. For this we have to find delta H. Okay, for that we have to find delta H, we have to find. So how much delta H we are getting in the sense minus 83.5 kilojoule, minus 83.5 kilojoule we are getting. Okay, so in the what is required equation in the sense enthalpy of formation of ethane that we got. So enthalpy of formation of ethane we got in this, in the required equation. Let us go to next sum. The standard enthalpy of combustion. The standard enthalpy of combustion at 25 degrees Celsius, at 25 degrees Celsius of hydrogen, comma C6H10, and cyclohexane, C6H12, or minus 241, minus 3800, and minus 3920, minus 3920, minus 3920 kilojoule per mole respectively. Kilojoule per mole respectively. Kilojoule per mole respectively. Calculate heat of hydrogenation. Calculate heat of hydrogenation. Calculate heat of hydrogenation of cyclohexene. Cyclohexene. What is the formula in the sense? C6H10. Cyclohexene C6H10. Okay. Sorry. Now we will see what is the given data. We will see. Given data is what in the sense? Standard enthalpy of combustion of H2. Combustion of H2. Therefore, H2 plus half O2 gives H2O. For this, delta H is how much in the sense? Minus 241 kilojoule given. Okay. Then combustion of C6H10. So C6H10 plus O2 gives carbon combining with oxygen to give carbon dioxide. Hydrogen with oxygen gives water. We have to balance this equation by keeping C6H10 1 mole. So 6 carbon and hydrogen 5. Here oxygen 6 2s are 12, 5, 12 plus 5, 17. So 12 plus 5, 17. Therefore 17 by 2 we have written. 17 by 2. For this, delta H is how much in the sense? Minus 3800. Okay. Then combustion of cyclohexane. Combustion of cyclohexane. Cyclohexane formula C6H12. This plus O2 gives carbon 6 times. Therefore, carbon dioxide 6 times. Hydrogen 12. Therefore, 6H2O. Oxygen is 6 2s are 12. Here 6. Therefore, 18. 18 in the sense 9 O2 we will write. 9 O2 we have written. For this, delta H is how much in the sense? Minus 3920 kilojoule given. Okay. What is the question? Means heat of hydrogenation. Hydrogenation means addition of hydrogen. Heat of hydrogenation of what in the sense? Cyclohexene. Cyclohexene formula is what in the sense? C6H10. Cyclohexene formula C6H10 plus hydrogen. Plus hydrogen means hydrogenation. Hydrogenation means addition of hydrogen. Addition of hydrogen gives what in the sense? C6H12. For this we have to find delta H. Okay, so cyclohexene plus hydrogen gives cyclohexane. For this we have to find delta H. Given equation number 1, number 2, number 3 equations are given. Using these equations we have to find it. Okay, therefore what shall we do? Equation number 1 shall we take as it is? So equation number 1 take as it is. Therefore H2 plus half O2 gives H2O. For that delta H is how much? Minus 241 kilojoule. Then equation number 2 shall we take as it is? Yes. Equation number 2 we have to take as it is. C6H10 plus 17 by 2 O2 gives 6 times CO2 plus 5 times H2O. Delta H is equal to how much in the sense? Minus 3800. Equation 3 you have to reverse. Equation 3 reverse it. 6 CO2 plus 6 H2O gives C6H12 plus 9 O2. Then delta H is equal to plus 3920. Now let us add all the equations. Before adding all the equations, let us cancel the common terms. Cancel the common terms. Carbon dioxide 6 times, water we have to cancel. Here 6 times water is there. Here 5, here 1 water cancelled. So oxygen is there. Here 17 by 2, that means 8.5. Here of 9 O2 get cancelled. So what is there means left side C6H10 is there plus H2 gives what in the sense? C6H12. Let us add all the delta H. We will get delta H for this required equation. We will get it. Okay. So delta H is how much in the sense minus 120.